Integration finds the exact area under a curve, and here is how it works, step by step. Integration is really the reverse of differentiation, so let's start there. Take x to the n. To reverse the power rule, we raise the power by 1 and divide by that new power. That gives us x to the n plus 1 divided by n plus 1 plus a constant, since the constant vanishes when you differentiate. Now, a definite integral goes further than just finding a formula. It gives you an actual numeric area between two x values. To do this, you evaluate the integral at the upper bound, then evaluate it again at the lower bound. Subtracting the lower result from the upper result leaves you with a single number, the exact area under the curve between those 2 points. The same idea extends to the area between two curves, not just one curve in the x-axis. Shade the region trapped between an upper function and a lower function across the interval where they overlap. Integrating the upper function minus the lower function across that region gives the enclosed area between the two curves. Some integrals are not straightforward to tackle directly. This is where substitution helps. We replace part of the expression with a single variable, u, chosen, so the rest of the integral simplifies. Rewrite the whole integral in terms of u, including dx becoming an expression in du, then integrate this simpler version. Finally, substitute back so the answer is written in terms of the original variable x, not u. Integration is not limited to flat area. Rotate a curve around the x-axis and it sweeps out a solid three-dimensional shape. To find the volume of that solid, we imagine slicing it into thin circular disks, each with area pi times y squared. Integrating pi times is squared across the interval gives the volume of revolution, turning a flat curve into a full three-dimensional volume. Full process. Step 1. Reverse the power rule to find the general integral of x to the n. Step 2. For a definite integral, evaluate at the upper bound and subtract the value at the lower bound. Step 3. For area between curves, integrate the upper function minus the lower function. Step 4. For a hard integral, substitute u for part of the expression, integrate, then substitute back. Step 5. For a volume of revolution, integrate pi times y squared across the interval. Watch out, the most common mistake is forgetting the plus c on an indefinite integral or forgetting to subtract the lower bound's value on a definite one. Simplified version. Integrating x to the n gives x to the n plus 1 over n plus 1 plus c. A definite integral is the upper bound value minus the lower bound value. Area between curves is the integral of upper minus lower. Substitution swaps in u to simplify, then swaps back. Volume of revolution is pi times the integral of y squared.